Hey guys, this is Coach Brian. I'm going to do a speed run through the 6.9 notes. These notes are very similar. They're actually the exact same in concept to the 6.8 notes. Everything is just in radians. Okay, that's the only difference. So a couple of reminders right here that 180 degrees equals pi radians, and 90 degrees equals pi over 2. So that'll help us get started as we move down here to our unit circle. For A through C, it says to use 7 pi over 6. 7 pi over 6. So we're going to start similarly to how we did on our last notes. We're going to start with our 0 and a full circle being 2 pi. If we go straight across from that, a half circle is pi, 90 degrees is pi over 2, and 270 is 3 pi over 2. So think like pi and a half. Now we can start breaking this up. If we go right down the middle, halfway between 0 and pi over 2 is pi over 4. And then this is a third of the little quadrant, so that's pi over, I got that backwards. It's a sixth of the top half, so that's pi over 6. And then up here, it's a third of it, and we got pi over 3. Now, if you remember from our lesson, there's a little pattern to this, 6, 4, 3, and then we've got a 3, 4, 6. And then we've got a 6, 4, 3, and a 3, 4, 6. So as we're working around, the numerator will change. It'll always be something pi, but those denominators go 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. So we're looking for 7 pi over 6. So if we were to, you don't have to do this, but if we were to kind of start shading in some sixth here, we would have 1, 2, 3, 4, 5, and then when we got around to pi, we would be at 6 sixths. So a way we could write that is 6 pi over 6. And so our seventh little kind of wedge comes right here. And at that location, we would have 7 pi over 6. So which quadrant does that terminate in? It terminates in quadrant 3. And the reference angle, remember, this is mentally, you should be thinking, what's the quickest way back to the x-axis? Is it to go this way, or is it to keep going all the way around? And obviously, the shorter path right here will give us our reference angle. And so when you're in quadrant 3, if you refer back to your notes, you find the reference angle by taking your standard and subtracting pi. So in this case, our standard is 7 pi over 6. And if we want to subtract pi, but we also need to have a denominator of 6, we would just say 6 pi over 6. And what does that leave us with? It leaves us with our reference angle, pi over 6. And then for the last section here, it says which trig functions will be positive. Just like last class, we need to remember that all students take calculus. And when we're over here in quadrant 3, represented by the letter T, that means tangent and its reciprocal, cotangent, will be positive, but all of the others will be negative. All right, I'm not going to spend too much time on this update because we did this during last class and nothing has changed. You just need to remember that when we're dealing with the unit circle, the hypotenuse has to equal 1. And so we have to, on both of these, manipulate them so that we don't change any of the ratios, but we force that hypotenuse to equal 1 because that's what it equals when it's the radius of the unit circle. And then lastly, on the 45, 45, 90, we have to rationalize both of these because we can't leave that radical down in the denominator. And so here are our updated special right triangles. And then down here, we just have them graphed out. We have the first one that it's kind of helpful if you extend this line and kind of put your angle out here. That value is what theta is in here. So this would be a pi over 6, which in degrees is a 30. So we have, in actuality, right, we have a 30, 60, 90. And then as we extend this one out, this is a pi over 4, which in degrees is a 45. That means this triangle is a 45, 45, 90. And then lastly, if we extend this radius or this hypotenuse out, this is a pi over 3, which is 60 degrees, making this a 60, 30, 90. So same special right triangles, and they have the same side ratios. So let's get into a few examples. I'll work just a couple of these. Remember, we're looking for the exact value and we want to rationalize when necessary. So let's start up in the top here with the sine of pi over 6. So if I graph out pi over 6, as you get more practice, you'll know that that's a 30-degree angle. Okay, that's a 30-degree angle. And if we just zoom in here and we kind of put our perpendicular line right here to form the short side of our right triangle, we now have the makings of a 30, 60, 90 triangle. And so the first thing I want to do is I want to label my radius as 1. My short side, remember my short side is always across from my small angle. That's going to be half of the hypotenuse. And also that's my vertical side. So I'm going to go ahead and label that with a Y. And then kind of the weird one for 30, 60, 90 is the side across from the 60. It's always the short side times the square root of 3. So that gives us the square root of 3 over 2. This is our lateral or our left to right side. And so we're going to label that X. And so we have an X and a Y and an R. And the sine of theta, if you remember from previous lessons, is opposite over hypotenuse. And another way that we can say that is Y over R. So in this case, 1/2 over 1, all right, sorry about that, 1/2 over 1. Well, any number divided by 1 is that number. It is itself. So the sine of pi over 6 is 1/2. Now, last lesson I worked the first 4, so I'm going to mix it up a little bit here. I'm going to jump down to F, where it's the cotangent of 5 pi over 6. I'm going to use that little trick that we talked about in lesson 6.7, where if you start with a 0 and you jump across, we can match this denominator, and so we can write 6 pi over 6. And then if we came back around to a full circle, that'd be 12 pi over 6. And up here at 90, that's going to give us 3 pi over 6. So that's helpful. Sorry, I'm going to rewrite that a little cleaner. That's helpful because now we can see where 5 would fall. It would fall over here in quadrant 2, and it would be closer to 6 pi over 6. So I'm just going to label this real quick. And again, as we learn our angles, you'll know that this is a 150-degree angle. All right, that means this side right here is 150 degrees. And that leaves us a reference angle, okay, this angle, reference, of pi over 6, which is 30 degrees. So as we sketch everything out here, we have a 30, 60, 90. And again, the best first step is go ahead and label everything. So my r is 1. My short side, y, is 1/2. And my x, my horizontal lateral side, is square root of 3 over 2. But see how from the origin I had to go left? I had to go left. That means that this is negative. When I'm in Q2, my x is negative and my y is positive. Also in this quadrant, this is all students take calculus. This is my S quadrant, which means sine and cosecant are positive. Well, right now I'm looking for cotangent. That means I should be expecting a negative answer. So let's talk about what tangent is. Tangent is y over x, which means cotangent is going to be the reciprocal, x over y. So I'm going to get my x value, and I'm going to divide it by my y value. Anytime I have to divide fractions, I'm going to need to keep, change, and flip. So I'm going to keep my first fraction. I'm going to change division to multiplication, and I'm going to flip my second fraction. And then a good habit is to go ahead and see that these guys right here will cancel each other out. And so my final answer will be negative square root of 3 over 1, which is just the negative square root of 3. Okay, so the cotangent of 5 pi over 6 is the negative square root of 3. All right, I'm going to jump down now because this isn't so different from last class and you need to do these for your own practice, but I'm going to jump down to the quadrantals. Quadrantals are when you get an angle that falls on one of the boundary lines, quadrant lines, the x-axis, the y-axis. So the hypotenuse is always +1, still always +1. The adjacent is still going to be the x value, and the opposite is still going to be the y value. And so what that gives us is that sine equals y over r, or just y, because r is 1. Cosine is going to be x over r, or just x, because r is 1. And tangent will be y over x. Now, if it helps you, go ahead and write the reciprocals out here, the cosecant, the secant, and the cotangent. And then you're just going to flip the originals. Now, for these, you can't leave out the r. You can't just forget about that 1 because it will mess up your answer. So we talked about this last class. This would be a 0-degree angle or a 360 or something coterminal. This would be a 90 or something coterminal. This would be a 180 or something coterminal. This would be a 270 or something coterminal. And then when we're putting that into radians, that'd be no pi or 2 pi. This would be pi over 2, this would be pi, and this would be 3 pi over 2. All right, so let's do a couple of these before the bell rings on me. All right, so let's do the cosecant of 3 pi over 2. 3 pi over 2 is right down here on the negative portion of the y-axis. This is 3 pi over 2. And this point is at 0, -1. So that's my x, that's my y, and the actual length of this line, r, is 1. So I have my x, my y, my r. If we go up to our list here, cosecant is r over y. R over y. So I'm going to take my r and divide it by my y, and 1 divided by -1 is -1. If you don't remember from last class, the answers to these quadrantals, all right, the answers to the quadrantals will always be either sorry, my box isn't perfect. 1, -1, 0, or undefined. So those will be our answers to all of these. I'm going to do one more, and I'm pushing it on the bell ringing here. -5 pi over 2, okay? Now, I need to find something coterminal to this, or I need to go in a negative direction. I'm going to try to find a coterminal by adding a positive term to it, all right? I'm going to add 2 pi to it, and that brings me up to -pi over 2, and I can actually work with that because a -pi over 2 is down here, essentially where a positive 3 pi over 2 would be, okay? So real quick, that's down at 0, -1. That's my x and my y. R always equals 1, and then sine theta equals y. So in this case, the sine of -5 pi over 2 equals my y, which is -1. Now, I know I skipped a lot. There's a lot for you to still do on here. Practice, practice, practice will make you better and will make it easier. So I hope this helped, and good luck.